Hey guys, how's everything going? This is JSer. This is the last video of my series on quick recap of Facebook questions. Okay, let's start. Let's continue from the last video, which is range sum BTS. So this one, it should be continuous subarray sum. We're given a non-negative numbers and target find if has continuous subarray at least two that sums to multiple of k. 0 is also counted, right? Well, so the idea is 2 plus 4, contiguous, right? This is size 5 and sums to 42. Well, we add the sum mods, which is the sum mods by 6. So we loop through the element and get the sum. Of course, mod by 6. If sum is 0, then all are 0. What does it mean? Only invalid case 0, so we fill this one case out. If sum is 0 and I is bigger than 0, I'm going to return true. So yeah, why we fill 1 0? At least 2, right? He says at least 2. At least 2. If sum is 0, then all is 0. All are 0. I bigger than 0. Why? But this is 0, then it's 0. Yeah. If the first one is 0 and then it's 0, then it's not. It should not be, because at least 2. Okay, then if we create a mod to see if it exists or not, and get the index, and we get the sum, and if it already have the sum and it is smaller than I minus 1 is before, then it means the subtraction is could be the multiple of k. Wow, if it is else, wow, it is super cool. We get the sum. Actually, it is the sum. It is similar to what we did before. Subarray sum would be the subtraction of sum from the origin, right? So if we get the multiple of k, it means the mod, the sum of mods to this one is sum of the mods to this, right? You see, this is the difference is 0. Cool. And of course, the at least 2 means filter the same different special case out. Expression add operators. We are given a number. Now, like this in strings, we need to add operators plus, minus, or multiply to make it evaluate to the target value. Well, this is backtracking. We create a recursion function, which is walk, which means start at a specific index, will end at last, right? And the temporary result would be to sum and to multiply. And the last parameter is the prefix, because at last we need to return the output of all possible strings. Okay, so for each case, for each round of iteration, we will loop through all the possible places to insert the operator, right? And if the start is 0, we cannot create double 0, so we ignore it and get the head, which is get the number. It's like 232, and pass it into number, and it gets the result if plus and minus is used. This is a result, and we get a prefix because we add a number in. Now so like we try with 3, Now, what is to be added to after 3? Well, there are 3 possibilities: plus, minus, time. If plus and times, actually the result will be to sum and to multiply. If it is times, then to sum is keep the same, but to multiply will times this hit. So there will be 3 possibilities, and then we will start with the next index and do this over and over again. And this is what actually try to test on all possible combinations. And the ending case is the I is got into the last one, right? This last one. And if we get the result is target, there's no more operators to the end. So suppose this is plus, so the result, if it is target, we push the possibility. Well, pretty straightforward backtracking. Closest binary search tree value. We have a BST, binary search tree, and we need to search some target, which might not be in it. Well, we just loop through, we just suppose it exists and find the path, and during the path, we compare each, the distance to the node, right? Compare each node to see if it is closest to the target and finally return it. There's nothing to address. Maximum swap. We have a number, we need to swap two numbers to make it bigger, the last one, the biggest one. Well, the idea is if we like 9973, it's descending, there's nothing to swap, right? Because it's descending, it's the biggest one. Suppose it's like 99273. Obviously, we find the first ascending point, which is 2, next one is bigger than it, and then find the biggest number, which is like 10. We move 10. We have 10, right? So it means we all swap 10 to the position is as small as possible. So we swap this 10 to 9. Yeah, we can get it bigger. So why are we searching for the turning point? Because if there's no turning point, it's descending. So we need to find it. The last one, because it's descending, there could be no number bigger than the previous one in left part of 2. So we need to find the biggest one in next half, and then swap it. So we first find turning point, and from this turning point, find the biggest one, and now from 0 to this turning point, find the first one as smaller than this, right? Yeah, max index to the right, and find the first smallest smaller than that, and the swap. Cool. Next swap is graph bipartite. Well, this is typical, like, okay, let's jump straight to the okay, DFS, maybe. DFS is better. Okay, so because we're going to separate it into 2 sets, we just say, suppose this is 0, okay, we use 3 status. One is on set for each node, one is 1 for set A, 2 is set B. We create a marks, which means this is set, it is marked or not, right? So we loop through all the graph, and if it is not marked yet, we mark it. But we mark it, we will mark the whole graph connected to it. Right? There might be isolated graph, so we use a for loop to check them. If it is not marked, we mark it as 1. It doesn't matter because, each one, because yeah, it doesn't matter. And we use a stack, we use DFS. While it is not empty, we pop the pop, and next mark we will calculate it, and for the we get the connected nodes. If it is not 0, it is marked already. If it is not marked yet, we mark it and push next node in it, right? And if it is already marked, we won't pass it in. We won't push it in. But if it is marked differently, we return false immediately. So at last we return true. Cool. That's it. BFS, DFS doesn't matter. It's graph traversal. Graph by the type random pick index. We have integers with possible duplicates. We need randomly output the index of a given target number. Well, first we get the index of each number, which is like this index map, and then we pick. So we get the indices and random, and it gets random. Yeah. This maximum of 3 non-overlapping subarrays. We're getting in 2, so it means the subarray with length of 2, like 1, 2, 2, 1, 2, 3, and we will need to find the maximum sum of 3 non-overlapping subarrays. 1, 2, 1, 2, 2, 6, 7, 5. They are non-overlapping. Well, we can first crush it into 1k equals 1. Means because for each starting index with the length of 2, we can actually calculate the sum by sliding window. This is linear time. We crush it, so it actually becomes an array of numbers, and we choose the maximum sum of any of these numbers, right? So if we're gonna get we fix the middle one, it means we need to, for each index, we get the maximum from left, maximum from right. So we can cache that. We cache the maximum items from left, cache the maximum right, and last with 1 linear time to get the maximum. Actually, I think we could merge these two into 2, right? Get the maximum from left, and actually we could get the result directly in this folder. But the time complexity doesn't change. Similar string groups. Similar, yeah. String. If some strings could be generated from a previous one by one swap, we call them similar. But all the similar strings are put into similar groups. But the strings in the same group doesn't necessarily mean they are similar to each other. Well, this is kind of graph. If two words are similar, we draw a line between them, and so we will draw a graph of the whole total words, right? And there might be some isolated trees, isolated subgraphs. So we will do what? We will pick them out, right? Pick one, and we can use DFS or BFS, anything. We pick the whole subgraph out. How to identify that? We use a marked set to mark each node as traversed or not, right? So you see, we first create is similar. If two words are similar, we just do that by counting the difference positions, and create a map, which means similar map. This will generate a graph, and then we fill out the map and use a traverse map to mark it if traverse or not. And for each word, if you fill the traverse, we continue. If not, it means it's a subtree. We counted 1, and then try to mark the connected string words, and then we return the count. Down. Pretty straightforward. Monotonic array. An array is monotonic. It's either monotone to increase or monotone decreasing. It's 1, 2, 2, 3, or 2. Yeah. Well, we can just detect if the previous one is strictly smaller or equal, or bigger or equal, right? I think we could just we determine how can I say, we can just determine a current state. If it is a current, say if it's ascending or descending or equal. If we met equal, we just keep equal. But if we met once we met ascending, it should be updated ascending, right? And if we already ascending and it's descending, we return false. Or the other way is we do it in a reversed way. We found something this, then we deny it's the opposite way. We found some ascending nodes, then the ascending is false. The opposite, and then finally we get the result by this OR. Last one, maximum difference between nodes and ancestor. Oh, so this is a tree. We need to get the maximum, difference, right, between 8 and 1. Of course. So to a node itself, from all the ancestor, what it needs actually, it needs the min max, right? Get the max, get the min. If passed in, we can get the difference for each node. So we can actually create a recursion. This recursion will receive a node and the min max from the parent. Okay, so we get the result, update the maximum difference, and get the min max comparing to current node and pass it on to the child. Well, so it's done. So this is a recursion. And now we can do it BFS. It's the same actually. We can rewrite it in BFS or DFS. It's done. Okay, so that's all for that's the last episode of my 5 video series of brief recap on top Facebook questions. Actually, in these 50 questions, there is like 3, 6, 9, 10, 40, 33 of 30. Wow, half of them I think are medium, and then one of the thirds are hard, and a similar easy one has like several. Yes, 1 out of 5. So, wow, this is are said to be the top Facebook questions. I need to trust them because I don't have time for any more investigation on different topics. So what I'm gonna do in today and the last 2 days, I will just to try to focus on these 50 problems again and try to, even I didn't understand it, I'll need to memorize the time complexity, space complexity, then the edge cases, and remember to practice clarifying the input and explaining my thoughts clearly. So there will be actually in next 2 days there will be no more videos. Wish me luck. Wish me luck, everybody. I'll see you on a Wednesday. Maybe if permitted, I will give a brief report on what I was asked. I will not give details, but I will tell you what it is about or how we should prepare it. Wish me luck. See you next time. Bye bye.